I want to have a look today at one of those biology core practicals on enzyme activity. Today we're going to investigate the effect of pH on the effect of enzyme activity. So what do we need for this experiment? Let's have a quick look. We want basically a few test tubes. Let's take a few. I'm not very good at drawing test tubes. And this one we're going to set to pH 4, pH 5, pH 6, pH 7, and I'll go for pH 8. I've set those up already today, and I've put some solutions in a water bath, and the water bath is set at 36 degrees centigrade. It's got to be below 37, and I've chosen 36. Also in the water bath I have another test tube with some amylase in there, and I've got also in there some starch solution. What we're going to do is we're going to add some starch solution to each of these, so it's going to be approximately that pH. We're then going to add a small amount of amylase to each of these. We're going one at a time, and I'm going to take that and I'm going to put that onto a spotting tile, and in the spotting tile I'm going to put some iodine solution. Now, the last time we did this experiment we did a idea of just trying to look at how well it worked. This time we're going to try and compare each of these. I don't know whether it will work properly or not, but we'll certainly have a go. And first of all we're going to do it for pH 4, and what we're going to do is about every 15 seconds we're going to take a drop of the solution of starch and amylase at a particular pH, and I'm going to put a drop in there. If the reaction has taken place, then the solution will be orange, and if it's worked it goes this blue-black colour. Right, so that's what we've got, and what we're going to do is we're going to try and investigate what happens. Right, so let's go over and have a look at the setup. Right, now what I've got is this solution. So we've got our water bath. The water bath is set at 36 degrees centigrade. I've got my enzyme. I've got my different solutions, and I've got my starch solution ready to go. Okay, I've got my spotting tiles, and the first thing that I need to do before we start this experiment is to set up the spotting tiles, and I'm going to put in 1 or 2 drops of iodine in each one. Unfortunately, there's no quick and easy way of doing this. We've just got to put in the iodine here. I have spared you all the setup because it did take quite a long time to get the buffer solution set up to stay at the right pH. Get the water bath set up at the right temperature. Make up the starch solution. Well, this is always fun when you actually come here for lessons, because I don't have a technician, so I need to get someone to make it up, and that's usually my student. Right, so we're ready to go on our first one. Now what I'm going to try and do is show you what pH these are, rather than try to take my word for it. That's going to be the right way up, I think. So we've got, there we are. Not ideal, but it'll do. So I'm going to put, get the right camera, I'm going to put the first solution in here. Let's have a look and see what this is. And so this is about 4. As best as I could do with it. Right, okay. So this is a pH of 4 solution. I'm going to take an amount of starch in there. Put 2 of those in there. I think I'll put that down before I knock it over. And what we're going to do is we're going to put a known amount of amylase in there in a minute. Now I'm going to use this one here just to take out a drop. So I'm going to take out a drop of the solution, which is more than I wanted there, and I'm going to put 1 drop on for the start of the experiment, and that's ideal. Okay, so what I'm going to do now is I want to get an amount of enzyme. Don't want too much. I want really about that much, and what we're going to do is we're going to squeeze in and we're going to start the stopwatch. For 15 seconds, we're going to take 1 drop. And we're going to take 30 seconds, another drop. Another 30 seconds, we're going to take another drop. Another 15 seconds, I'm going to take another drop. Another 15 seconds, I'm taking another drop. Another 15 seconds, I'm taking yet another drop. I'm going to go down as far as one spotting tile. Let's take another drop. Another 15 seconds, we'll take another drop. And we're seeing not a lot happening, which is what I would expect, because this is pH 4 and the enzyme doesn't work well at pH 4. So 2 more to go. We take our next one. And let's take our last one. And I'm reasonably convinced that this didn't work well. Right, okay, so we've looked at pH 4 and what we're seeing is nothing happening here. Right, so let's put that tile aside and I'll clean that up in a moment so we can use it again. And what we're going to try now is looking at pH 5. Now I've finished with that test tube. I'm just going to take it out. Put it out of the way, and we're now going to work on my next solution, which is pH 5. Right, so let's put in the required amount of starch. So I've got my starch ready to go, and I'm going to get another couple out. Right, so let's take some enzyme. And I'm ready on the enzyme. Ready. Looking ready on the stopwatch. 3, 2, 1, go. I didn't bother with one that was set at 0 this time. And 15, we take a drop. Let's take another drop. Coming up on 45 seconds. We're getting some activity going on here. Let's come up on 60 seconds. 1 minute 15. Virtually gone this. We're going to probably do one more. And I'm convinced that has finished. So there's our second experiment. Now I suppose I'd better record some of these results because it's always a good idea to try and do that. So our set of results, I've got my pH of 4, my pH of 5, and for my pH of 4 then I took some every 15 seconds and there were 12 tiles and it didn't go in any of those. In this experiment, and we'll just zoom in on this, you can see 15, 30, 45, 1 minute. I think really we can say that really by 1 minute it had virtually gone. 1 minute 15, definitely by 1:30 it had actually stayed orange. So we've got that one to worry about. Now I find my best way of trying to record some of my results is, let's just take a picture of it. And that's as good a way as any of recording my results. So we've got to try and make a decision now what's actually happening, and we can see that at here 1 minute we've got it slight, 1 minute 15 virtually gone, and by 1 minute 30 seconds completely gone. Alright, so I've got an idea about where we are with that one. Now let's have a look at pH 6. So I've got myself ready to do pH 6. I've got also a clean one here ready to set up to do the next experiment. So we'll just set up the iodine solution. Often when you do this in school there's a few of you doing it. Here it's just me. So we've done our second experiment, so I'm going to move that one out of the way, and I'm now ready to start my third experiment. So this time we're going to look at pH 6. I've put the iodine solution ready. I've put my starch solution in. So we're now ready to put in my amylase solution. Ready on the top watch. 3, 2, 1, go. What I'm doing is just mixing it up a little bit. And let's take our first sample. That's gone blue-black. Coming up on 15 seconds for my next one. So this is 30 seconds. That's starting to go. 45 seconds. And that seems to be virtually complete. I will do another one just at 1 minute. Here we go, 1 minute. And we're not seeing any change there. So that experiment is now complete. And we're looking at, for pH 6 here, well, let's bring this up so the camera can see it. I'm going to record this. So there's my pH 6, and what we've got there is started to go at 15. By 30 seconds it had nearly gone. By 45 seconds that was complete. So I think our complete's probably our best place to go for this. So let's put in here it was complete by 45 seconds. pH 7 is our next one that we're going to have a look at. I'm anticipating this to be the fastest, but we will see as we go. So I'm going to take my starch solution, I'm not that bothered about my water bath getting a bit dirty. Right, so we have this solution ready to go. Get another clean pipette and let's take a sample of amylase. And we're ready on the stopwatch. That amylase is starting to escape in there, it's alright. Ready, 3, 2, 1, go. Right, giving it a good mix. Coming up on 11, 12, 13, 14, 15 seconds. And that's a bit more black than the other one was on the last one, but we'll see how we go. Coming up on 30 seconds, 30 seconds. Let's see what it's doing. And that reaction is nearly gone. "45 seconds. Virtually gone. "1 minute. That's gone. So I'm not seeing any change now. So with this one, pH 7, we're looking at blue-black. It's nearly completed and it had gone by 45 seconds. So that's that one done, and I'm now left with doing my last one. Let's take my starch solution. So this one's going to be pH 8. I've finished with my starch solution, I'm just going to move that out of the way. We want another clean pipette, and we'll get the last of the amylase out. We're ready on starting. 3, 2, 1, go. Right, 15 seconds. I'm going to do it on this next row here. And that's starting to go. 30 seconds. "45 seconds, and that's more or less gone. We'll do 1 minute just for the sake of doing 1 minute. And that's complete. So this is pH 8. And here we can see it's really gone by 1 minute. Still slight amount there. Difficult to say really. Let's on 1 minute for that one. We've got the same sort of time really with the other one. That one was also sort of gone in that time. Okay, so let's go back and have a look at the results. And what I'm just going to do is going to turn the water bath off. Quite a few people like my water bath. We use a sous vide, which will keep the temperature exactly right, and it's just a little box here. Probably one of the cheapest and most effective boxes that I've got for doing this. I'm just going to keep my pH meter safe. I will put up the right solution in here a bit later, but for the time being that will protect it. So there's my pH meter, everything is there, safe, ready, so we can do some clearing up later. And let's go and have a look at the results. Right, so I'm back where I was, and we can have a look and see what we've got. So we can see some things about this experiment. We can see that at pH 4 I managed to clear up the whole spotting tile of basically 11 sort of spots, and it still hadn't gone. At pH 5 we're looking at around about 1 minute 30. pH 6, it seems to be about 45 seconds. pH 7, it seems to be about the same, perhaps slightly longer. pH 8, about 60 seconds. So let's have a look and see what we've got. Right. Now, let's see. Can we sort of work out some sort of graph here for what's going on? Right, let's draw in an approximation for what's going on. So let's draw in, we've got pH 4, 5, 6, 7, 8, yeah, not going to see that well. Right, so if we say this one's pH 4, pH 5, pH 6, pH 7, and pH 8. Now, what are we seeing here for times? So let's draw up here different amounts of times. So we can have 15, 30, 45, 1 minute, 1 minute 15, 1 minute 30, 1 minute 45, 2 minutes. So let's put them in 15, 30, 45, 60, 115, 130, 145, 2 minutes. So I can do that one as 1 minute. Right, this is going to give you a different shaped graph than we imagine. So this one's way up here. pH 5, we've got about 1 minute 30. pH 6, we're down to about 45. pH 7, maybe a little bit longer. And pH 8, slightly longer there. Let's do it at 1 minute. And so that's giving me a graph that's looking something like this. Usually when you see these graphs, someone will plot them the other way up, and they'll give you a graph of enzyme activity that will look like that. We haven't done that type of graph, so we've got just some feeling for how the thing is going, and we can see that our optimum pH is somewhere around here. We've got somewhere around about pH 6. pH 7 seems to be our optimum. Now, if I could take some more readings around here, we could do better. So what we could do as an improvement to this experiment is to take several different pHs, pH 6, pH 6.1, pH 6.2, and I'd have to set up lots of different buffers to do this. What I've done is just set up with the buffers that I had to get the right sort of pH, and it gives me an approximation, and we can see that we have got, albeit not brilliantly, we've got some of these figures. We could also improve, so that would be improvement 1. So improvement 1, we could have a finer pH scale. and we use pH buffers to keep them at the right pH. We could simply take more readings. We could also do our favourite job, which is to repeat this experiment. The enzyme I used was fresh, but even so, it was at a different age from the first experiment to the last experiment. And did that make any difference? I would hope not. The enzyme should have lasted at that temperature and that sort of time. So we've got basically a feeling for this particular system, that we can see this experiment, and that's the sort of thing that you would use in a core practical. These core practicals often come with a series of questions that you can be asked, and the sort of things that we get are things like, at which pH you tested was the enzyme working the most efficiently? And we could guess that that's going to be, for this experiment, somewhere between pH 6 and 7. I could make a guess at pH 6.5, but I mustn't do that. And the reason that I can't do that is I haven't actually done the experiment to show. How could we find a more exact optimum pH? We could use finer buffers, pH 6, 6.1, 6.2, 6.3. At which pH values does your amylase not work? Well, we can see it didn't work at pH 4. So the other thing I could have done was I could have increased the pH. We could have done readings at pH 9, 10, 11. And we would have found, had we done those, that it didn't work well at those. We also need to think about here control variables, things that we need to control. So here we used the temperature was kept constant, and not as accurately as I could have done, we used the same amount of starch. In fact, by putting 2 pipettefuls, I was pretty accurate on how much I actually used, and I could have perhaps been a little bit more accurate on the amylase. But the amounts I used were within about 0.1 mils, so as far as I was concerned, I was reasonably accurate on those. So we controlled the amount, we controlled the temperature. I used the same starch solution, and I used the same enzyme. So these are all the things that I've kept under control. So I hope you found that experiment interesting. I hope you found that one useful. If you don't get the opportunity to do one, which you really ought to, then you've got my results that you can actually use if you need to, and you can then perhaps investigate in more detail, or just take it from me that I did that one as accurately as I could. Until next time, next week, I'll see you. Take care, and if you found it useful, then you can always subscribe. Thanks for watching. Bye bye.